So I'm going to give you a short introduction to service discovery and self-organizing cluster orchestration. Modern web application consists often of multiple hosts like load balancers, application servers, workers, database servers. And most of the time their configs are hard-coded. So IPs of nodes are hard-coded in configs. And imagine the situation when one of the nodes in this picture fails, for example, APP1. So in worst situation, you rebuild this node and it gets the new IP. You SSH into load balancer, change the load balancer config, input the IP of this node, then you SSH to every of workers, maybe change the firewall rules to whitelist the IP of this node. So the infrastructure becomes a bit of monolithic. It's modern word, everyone likes it today. So in this hard-coded environment, you don't even need the service discovery. It works as is. But someday you face the problem of scaling. Like, for example, you run the e-commerce service and Black Friday comes. You expect double the number of requests, so you have to double the number of your app servers. The Black Friday passes, Cyber Monday comes. You still need those servers, but on Tuesday you don't need such a big number of hosts, and you delete them, and then you have the problem of changing this config. One day, and you find that you have to react on some events and change your infrastructure according to those events, maybe changing load, etc. Then you have to answer the question like, who is the database master today, or which IP addresses do the application servers have? So basically you need to know which devices are in cluster now, which IP addresses do they have, and which services they provide. So knowing this is the service discovery. This was painted by my wife, actually. And I'm going to introduce you two solutions from HashiCorp, which allow you to build service discovery in your cluster. They are Serf and Consul. So Serf is, you want to take a photo?
Yes. Thank you very much.
Serf is decentralized solution for cluster membership, failure detection, and orchestration. It's lightweight and highly scalable and available. Three basic problems which Serf solve is cluster membership, failure detection, and events and queries. So let's start with membership. Serf is based on a highly available and reliable and extremely fast GOSI protocol. Nodes within the cluster exchange with short messages up to 1 kilobyte. And these messages are propagated within the cluster very quickly. So membership provides two basic events for cluster: member join and member leave. Each node of the cluster can handle these events in a custom way using handle scripts. Next, Serf is able to quickly find the failing nodes in cluster and quickly notify all the alive members about this. So member failure event will be propagated within the cluster in a second, and again each node can react on this in a custom way. In addition to these three events, member join, leave, and failure, Serf allows you to use custom events and queries. The difference is that events are using the fire and forget mechanism, while queries are designed to be request and response feature. For example, you can use custom events to trigger deploys, update configurations, and so on. And custom queries can be used to gather some kind of information from every node within the cluster, like gather the health status, maybe free space on the file system, etc. So it's pretty cool stuff, but what can we apply this for? With Serf, you can easily build clusters of web servers and load balancers. For example, when the new application server brings up, load balancer can fetch the list of application servers IP addresses and update its config accordingly. So same as above, clustering memcached or Redis. Each new node appearing in cluster can be quickly added to the config of your proxy or application. Using custom events, as I said before, you can build your custom deploy solution. For example, you trigger the event, worker nodes stop processing queues, application servers begin to update code, cache servers begin to warm up the cache, and anything you need to correctly deploy your application. Using Serf, you can easily update the DNS records if you use them in your web application or any application cluster. So node brings up, it registers within the DNS server, and DNS records are updated. Using custom queries, you can, as I said before, fetch any kind of information like status of your servers, health checks like CPU load, free space, so any kind of information you want to fetch from your nodes. While Serf is a low-level solution for service discovery and it doesn't provide full spectrum of features that are required for service discovery, it can be used as a basic block, like a first level of building your own custom service discovery solution, answering the basic question which nodes are online, which are alive, which services they provide, and which addresses do they have. So we made a short demo of simple cluster of database server and application server. We want to do this fancy stuff like when the database server fails or goes down, we want the application to return service unavailable or some fancy maintenance page for end users. You see the Nginx config on the application node is pretty simple. When there is a maintenance.txt file in the document root, we just return the service unavailable status code. So database server goes down, member failed event is propagated within the cluster. Application server has the member failed event handler, which simply adds this file to the document root. Database server returns, and now it's alive. Member join event is propagated within the cluster. We remove that file. So we made a short video, as showing it live on the conference is doomed to failure, as we know. So short video, how it works. Oh, it's doomed to failure too. So we built nodes using the Vagrant. I will talk a bit about it later. So this is a fancy page for users. And another video to show custom events and queries. It's not so funny as previous. We are bringing 3 nodes up here. So you can fetch the list of cluster members using the serf members command. So here we send in the custom event deploy with this payload.
Custom user.
So the event has been dispatched. We can see the result in logs. So here it is. And the custom query. So you see each node responds to the custom query. It's just a demo of another custom query. So that's it. Another tool for building service discovery solutions provided by HashiCorp is Consul. It's service discovery and configuration tool, highly distributed, highly available, and data center aware. So Consul solves these main problems: service discovery, health checking, multi-data center deploys, and data storage. Each node joining the Consul cluster can consume or provide some service like API or MySQL or other. It can easily fetch the configuration required to consume other services from the Consul server. While Serf provides only 2 available out-of-the-box health checks, like is node alive or not, Consul has a built-in support for any number of health checkings, either related to the servers, like the longest query from database or current HTTP status from web server, to health checking that are related to the node itself, like CPU load, free space, and other. Consul has built-in support for multiple data center deploys, so you don't need to design some level of abstraction to scale your application to multiple regions. And the last one, Consul includes built-in key value storage, which can be used to store dynamic configuration, some feature flags, and so on and so forth. You can use it for anything you need, and it is accessible via simple HTTP API. This is the common Consul cluster architecture. It includes 2 data centers which communicate via wide area network. They include 3 Consul servers. I will tell you why 3 later, and some number of clients. Clients communicate within each other and within servers via gossip protocol. So what's the difference between the Serf and the Consul? So, Serf is fully decentralized and doesn't require any servers, any central servers to operate, while Consul requires 1, better 3 or 5 servers to operate and maintain redundancy and key value storage to be safe. Serf provides only basic health checks, like a node dead or alive, and as said before, Consul includes rich health checks. As by design, Serf is designed to operate only via local area networks and may work via wide area networks, but with degraded performance. Frankly speaking, Consul uses Serf as a basic layer, but encapsulates this gossip protocol to communicate among multiple data centers. Serf is a more general purpose tool, again, which may be used like a basic layer of service discovery and custom solutions for service discovery. While Consul may operate out of box, and it requires some infrastructure to be run. And the consequence of decentralization, Serf doesn't require central services and will operate until the last node is alive. While Consul, again, requires some infrastructure to run. So, to sum everything up, now you can treat your configurations as a code. You can template them, configs, update them on the fly, and build them according to some changes in environment. Service discovery is a scaling and recovery. And there are some nice tools exist for building your solutions. By the way, HashiCorp provides some more fancy stuff for DevOps and developers, like Vagrant, which is a tool for spinning up development environments which are reproducible and easily transferred between the developers. We used the Vagrant to bring up nodes in the sample videos. Packer, which is a tool to build images for mostly all cloud providers like Amazon, OpenStack, and others via only single configuration file. Terraform is a tool for managing your resources, like bringing up nodes, bringing them down. It includes some cool plugins to operate on the Amazon cloud, and another. The vault is a secure storage for some sensitive information, like passwords, access tokens, and everything you want to be safe within your network of your servers. Nomad, which is the tool for, I don't actually remember. And the last one is Auto. It's some newly introduced tool for which is able to automatically discover your web application or your application type, prepares the development environment, and automatically prepare the deployment solution for mostly all. I don't think it's mostly all, but when they first showed it, it was only for Amazon. Yeah.
Yes.
And Atlas. Yeah.
May I ask you
Sure.
a couple of questions? Could you please elaborate on the common topic of distributed system, which is partitioning and consistency as a consequence of system partitioning? So how does, is there any quality of services regarding consistency, as well as is there any limit of nodes when system starts degrading?
Serf clusters are eventually consistent. So they are consistent while there are nodes and the Serf agent are run on these nodes. Consul cluster is consistent while the needed amount of central services are still operating.
And what about the limit of
The limit is 3 nodes. At least 3 nodes should be in Consul cluster for failover decision.
it's minimum 3 files?
Yes.
And
It's
about
because
No.
2 cannot
Yeah.
recognize the failure of 3.
You mean the number of total nodes in the cluster?
yeah, when the system operates normally without degrading functionality.
There is no limit.
There's no top limit of number of nodes.
Okay.
Only button.
But as far as I know, it's recommended to at least 5 because when one node is out, they start to decide who is better. And if you have 3 nodes, one node is out and entire cluster is out because 2 nodes can make decisions.
Okay, thank you.
No questions? Then